Hello Year 8. We're going to be looking at Pythagoras' theorem, which is based on right angled triangles. It's a really important concept because you're going to be using it from year now all the way through up to year 11. And if you choose to do maths or science at A level or university, it still gets used at that level. So it's a very important thing for you to understand. We're going to take it nice and steadily, so don't worry about it just yet. Pythagoras' theorem is all about right angled triangles, and we can use it to either find out if a triangle has got a right angle, or if we know two of the sides and we know it's a right angle, we can use it to find out a missing side. There are many ways of proving Pythagoras' theorem. We're going to go through one so that you know that it's an actual truth, but you might want to do a bit of research to see if there's another one that actually you understand a little bit better. So, here's the proof. Here, I've got two squares. They are exactly the same. Each side is A plus B. You can see that on both of these pictures. In this, I've got four triangles. Each triangle is exactly the same, and I've got four triangles here, and each of those are exactly the same. And therefore, the areas that they cover must be equal to each other. The red area in this example is C squared, where C is the length of the longest side of the triangle. But in this, the two squares are equal to the squares that fit on to the shorter sides of the triangle. So this one is A squared and this is B squared. But because the area of each of the large squares in each case is exactly the same, and the four triangles in each case are exactly the same, these two areas must add up to the same as this area. And that's where we get our Pythagoras equation. C squared is equal to A squared plus B squared. In every case, we have a triangle, and we denote it as a right angle using this little square in the corner. The longest side of a triangle is called the hypotenuse. You know where it is because it's diagonally opposite the right angle box. You need to know that word because it's going to come up again in the future, but the longest side of a triangle is called the hypotenuse. So the rule that we have is that C squared is equal to A squared plus B squared. In some cases, people prefer to remember it as A squared plus B squared equals C squared, because then ABC runs nicely along in the alphabet. It's up to you which way you prefer to learn it, but it's important to remember that A and B are the short sides of the triangle and that C is the hypotenuse, and we always use that lettering. So Pythagoras' rule can be used to find out whether a triangle is a right angle one or not. Because if we know what the three sides are, we put the numbers into this equation and we find out if the equation is true, if it's an identity. If it's true, then I know that the triangle is a right angle. If it isn't true, then there's no way that the triangle can be a right angle at all. We can always find the missing length if we know what two of the sides are, whether it's the two short sides or the hypotenuse and one of the other short sides. We can use it to find out the missing side. And that's what we're really going to focus on in this piece of work. So we're going to focus at the first place on finding the hypotenuse. The hypotenuse is the longest side. So we're going to use the rule as it stands. We're going to find the longest side squared is equal to the shorter side squared plus the other short side squared. This is how it works. Here is an example. I've got a triangle. I know it's a right angle because of this little box. And I've got two short sides where I know what they are. And I've got the hypotenuse where I don't know what it is. So I'm going to use Pythagoras. And I'm going to use the system that is C squared is equal to A squared plus B squared. And I'm going to substitute the values I can see into the right spots. So C squared is X squared, A squared is 5 squared, and b squared is 12 squared. So I'm going to substitute those values into the equation. I'm now going to work it out as far as I can go. So x squared is equal to 25 plus 144. I'm going to add those together, so x squared is 169. And the opposite of squaring something is to square root. So to find x on its own, I need to square root 169. Now we've talked in the past that when you square root a value, you get a positive answer and a negative answer. But because we're talking about a length, a physical size, we cannot have a negative length. And so for this piece of work, you would only take the positive value. So the square root of 69 would be 13 centimetres. That's the structure that you need to set out your work. Putting in the values, write down the equation, put in the values, work out the values, square root the answer, and then you find your result. Let's look at another one. This one, the triangle is drawn slightly odd. It's not sitting on its side like it normally does. But I know it's a right angle because of the square, and so this must be the hypotenuse. So I've got the two short sides. Key question here to decide whether you're going to add the sides or take them away is to say, am I looking for the longest side, the hypotenuse? If the answer is yes, then you're going to do adding as part of the problem. So here we go. I'm going to write down the rule. I'm going to substitute the values, and then I'm going to start working it out. So x squared is 36 plus 9, which gives me 45. I'm then going to square root that, and my answer is going to be 6.71. Do check with the question what accuracy you need to give the answer to, because that's where most people make mistakes. So that's how you find the hypotenuse. A couple of examples for you to have a look at. I'm going to now look at the other sort of question, when you're looking for a shorter side, one of the two that make up the right angles. In this case, you're going to have to rearrange the problem. So instead of having c squared at the front, you want one of these two. Don't worry about which one. I'm going to change it so that a squared is at the beginning. So what have I got? I'm going to try and get rid of the b squared, so I have to take it away from both sides. And that leaves me with a squared is equal to c squared minus b squared. So when I am looking for a short side, ask yourself the question again. Am I looking for the hypotenuse? In this case, the answer is no, so I know I'm going to take away. And you're always going to do the big number, take away the little number. Okay, so let's have a look at a problem. So here, I've got the hypotenuse. So am I looking for the longest side? No. So I know it's this formula. The a squared is equal to c squared minus b squared. Again, I'm going to substitute the values I've got. So a squared is 26 squared minus 10 squared, which means that I've got 676 minus 100. So a squared is 576. And when you square root 576, you get the answer 24. So it's exactly the same layout, but this time I am not looking for the longest side, and so I'm going to take away instead of add. That is how you do Pythagoras. And the key question, are you looking for the longest side? Yes, you will use the adding formula. No, you will use the take away formula. You now need to go through this a couple of times. Make sure that you really understand what I've said. If you have any questions, note them down and ask them on Sunday. And then on Sunday, we're going to do loads of practice so that you get very familiar with how to use this. We're going to start with problems like this that are quite straightforward, and then we're going to move on to problem solving, where they're actually giving you the question in a real life context. But it's still the same calculation, but you might have to draw the triangle and decide where the numbers go first. So have another look, and I'll see you on Sunday, and hopefully we will sort it out. Bye.